Hello, today I'm going to be showing you how to solve the USACO 2015 December Bronze Problem 3, Contaminated Milk. So the problem tells us that Farmer John is hosting a party with N of his friends and M types of milk, and one of them has gone bad. And Farmer John doesn't know which one, but anyone who drinks that bad milk will become sick either during the party or afterward. And we get a transcript of what happens at the party with N, M, D, and S. And D tells us the number of times, or I'm not sure the best, logs, I guess you could say, logs of time that tells us who drank what milk when. And then each one, person drinks type milk M at time T, and then the next S line states that person one gets sick at time 3. That means any milk he drank time 3 and before is a bad milk. Could have been a milk that got him bad. And if one of them is out, and the same thing for this one. And so, oops, wrong. So, so we are given the times and the person who drank the milk at that time. And so the best way, what I was thinking was we could solve this. We could have a hash map that describes each time, or I'm sorry, so at each time we can analyze this like a number line. Alright, time 1, 2, 3, 4, 5, 6, 7. At time 1, person 1 drinks milk 1. So we have person 1. So who drank a milk at time 1? Well, person 1 did. Person 1 drank milk 4 and milk 1. And no one else drank any milk at that time. So that's from that time. Now time 2 comes time 2. Person 1 drinks milk 2. Now time 3. Person 3 drinks milk 1. Time 4. Person 1 drinks milk 3. Time 5. Person 2 drinks milk 1. And at time 7, person 2 drinks milk 2. Alright. And so we want to figure out the minimum number of we want to find the minimum number of doses of medicine that will guarantee Farmer John so one dose of medicine will cure one person, and so we want to figure out the maximum. We want to find the minimum number of doses, but we also want to find the maximum number of people that could have been sick by any of the milks. And so we know person 2 got sick and person 1 got sick. So we know person 1 and person 3 have gotten sick. Sorry, person 1, person 3 got sick. And alright, so we know that these 2 people got sick. Person 1 got sick at time 3. So anything after this time, anything after time 3, any milk after time 3, person 3, or that milk could have been bad if person 1 drank it. And time 8 is over here, out of the distance, so anything 7 below, anything from 7 to 1 could have been a bad milk if person 2 drank it. And so we can see that person 2 drank milk 2, and so we can gather a list of possible milks that could have been bad. And only one milk can be bad, and so we want to make sure that both person 2 and person 1 drank this milk. And we can see that person 2 drank milk 1, milk 2. Person 1 drank milk 1, 2, 3, and 4. And so we can see that these 2, milk 1 and milk 2, are the only possible, we want to find the number of milks that both, we want to gather a list of the number of the milks that both people have drunk, and all sick people have drunk. And so then, once we find that, we need to figure out the number of doses of medicine. And so we see for each one of these, so we can see at time 1. So if milk 1 has is the bad milk, we need to get 1 dose of medicine for person 1, another dose of medicine for person 3, and another dose of medicine for person 2. And that's 3. But we're not done, because we need to now go through to check for milk 2. And we want to find the maximum. We want to find the maximum number of doses. Because we want to find the minimum number of doses that we need, because we don't want to give everyone doses of medicine, but we want to give all the people who could potentially have gotten sick medicine, and that includes person 3. So if milk 2, we want to get person 2 a dose of medicine, person 1, and so that would be 2, but you can see that the output is 3, and so we would get the maximum between those 2. And here is my code doing that. So we have import our libraries, reader output, reader MMDS, our maximum, and now this is our timestamps, and each one of these little periods is as a timestamp, and each time corresponds with another hash map of a person and the number of milks that they drank during that time. And I ordered it using tree map. And then we have a sick. What time did that get sick and who was it? Initialize everything here. And then now we get our sick people, initialize that. And now we get a hash set of possible possible milk types, yeah. And we go through the map of sick people, sick person, what time, and now here this is the possible values for this particular sick person. As you can see, person 1, he has milk 1, 2, 3, and 4 that could have been possible contributors to his sickness. Oh, I'm sorry, not three. Just 1, 2, and 4. And so we can see that person 2 did not drink milk 4, so we don't even need to. We can't include this because person 2 did not drink it, and so we want to only get ones that both of the people have it. So then we check this. We check this little thing. This is getting all of the elements that could have been possibly contributing to that. And then we get, if the number of possibles that we have is equal to 0, that means for a fresh start. Then we can just add everything else. Well, now we need to get another hash set of common milks and then add that to our new possible. And then this one, and then this final loop goes through and gets the amount of people that could have been possibly sick from each of these milks. And we check. And then we get this part. And we go through each of these sick people, and if we haven't seen this person, so what we're doing here is we're going through each timestamp and each person milk, each thing that they drank in that timestamp, and if this list of milks contains this possible milk and we haven't seen it, that person can increment our count and add that to our key. And basically, if our sick person has not been seen, then we don't want to even include that. So that's why we have this Boolean bad. And if you submit it, 10 out of 10. Alright. That is all.